Hello, in this lecture of the Essential Calculus problem series, I will solve limit as x approaches 0, x times sine 1 over x. First, let's start by checking whether direct substitution works here. We have x approaching infinity, x is infinity here, and sine 1 over infinity is 0, then we get infinity time sine 0 is 0. So we get 0 here. So we have infinity times 0, and this is an indeterminate form. Because direct substitution fails here, we need another approach. And we need to rewrite the given expression. The key idea here is to turn the given expression into a known limit. We know that limit as x approaches 0 sine x over x equal to 1. And we will use this fact here. This is one of the most important limits in calculus. Whenever you see a sine function, look at the expression inside the sine. And we have here sine 1 over x. Whenever we have a sine function, we should look at the expression inside the sine. For the standard trigonometric limit, the denominator must contain the same expression as sine has here. If it is not there, you need to create it. For this problem, we have 1 over x here inside the sine function. So we want to have the same expression 1 over x in the denominator as well. For that reason, I will rewrite the expression here. I can write this as limit as x approaches infinity sine 1 over x. Now, I will rewrite x here as 1 over x in the denominator. Now, I have the same expression here, sine in the denominator. And I know that if x approaches 0, 1 over x approaches to if x approaches infinity, 1 over x approaches 0. And let's define as u, let's define u as 1 over x. Then we can say that if x approaches infinity, u approaches 0. Now, for the expression here, we know that x approaches infinity, and I will say that limit u approaches 0, because I know that if x approaches infinity, u approaches 0. Now, sine 1 over x, I will rewrite it as u and divide it by 1 over x, and I will rewrite it as u. Okay, now we have limit as u approaches 0, sine u divided by u, and we know that this is equal to 1. And the answer of this limit is 1. And in the next video, I will solve limit as x approaches 0, tangent 3x divided 5x. See you in the next video.